This video covers section 10.4, graphing quadratic functions using transformations. Objective 3, graph quadratic functions of the form f of x equals ax squared. When graphing a times x squared, we're going to change the shape of the parabola. The parabola, as we know it, y equals x squared, goes over 1 up 1 and over 2 up 4 and over 3 up 9 and over 4 up 16. That's x squared. But when you graph 2x squared, it doubles all of those. Over 1 up 2. Over 2 up 8. Over 3 up 18. It doubles it and makes it a steeper parabola. So if g of x equals x squared, goes over 1 and up 1, and over 2 up 4, and over 3 up 9, it does the same thing on the left side. 2x squared two times 1 squared is 2. 2 times 2 squared is 8. And the negatives of those, squaring negative 1, it's positive, times 2 is 2. And negative 2 squared is 4 times 2 is 8. We're going to see the same kind of shape, but just growing faster. So we have 1, 2, 0, 0, 1, 2, 2, 8. Negative 1, 2, negative 2, 8. We say the graph of f of x equals 2x squared is obtained by stretching the graph of g of x equals x squared. Stretching it by a factor of 2. I like to say it makes it go steeper. Whereas you put a 1/4 in front of the x squared, and it's going to make the graph go wider. Zero, 0 still. Original graph 0, 0, 1, 1, 2, 4, 3, 9. And the new graph then, 1 squared is 1 times a fourth is a fourth. 2 squared is 4 times a fourth is a 1. And 3 squared is 9 times a fourth is 9/4, or 2.25. The negatives do the same thing. Negative 1 squared is 1 times a fourth. Negative 2 squared is 4 times a fourth is 1. And negative 3 squared is 9 times a fourth is 9/4. So our new graph is going to go through 0, 0, 1, 1/4, 2, 1, and 3, 2.25. And because we can fit this on there, 4 would be 16 divided by 4 would be 4. And then the same thing on the other side. Negative 1, 1/4, negative 2, 1, and negative 3, 2.25, and negative 4, 4. I say the graph of f of x equals 1/4 x squared is obtained by widening the graph of g of x equals x squared by a factor of 1/4. So the graph of f of x equals 2x squared is obtained by making the graph go steeper, and 1/4 x squared is obtained by widening. And I do believe they call this, I don't use these terms, so I'm hesitant to write them, but this is called compressing because it compresses it inward. And this one is called stretching it because it stretches it right and left. I like to say steeper and wider. Now here are two practice problems for you to try. I would like you to try on your own and figure out what this negative is going to do to the new graph. Please press pause in your video and work these out. And when you're ready to see the solution, come on back. Now that you've had a chance to work these out, I'll work these out with you. So again, the graph of g of x equals x squared goes over 1, up 1, and over 2, up 4. Left 1, up 1, and left 2, up 4. Traditional parabola. Now the f of x equals negative 2x squared. The 2 on it is going to make it go steeper, but the negative on that 1 squared is 1 times negative 2 is negative 2. 2 squared is 4 times negative 2 is negative 8. So it's not only going to make it go steeper, but now the new graph is going to be going downward. Negative 1 squared is 1 times negative 2 is negative 2. Negative 2 squared is 4 times negative 2 is negative 8. So now we're getting into what are called reflections, reflecting it about the x-axis, flipping it over, we like to say. So we say the graph of negative 2x squared is obtained by reflecting about the x-axis and making it steeper. By a factor of 2. So the negative in front of it has the effect of reflecting about the x-axis. So the same thing is going to happen in practice 4, except for the 1/2 is going to make it wider. So a traditional graph, 1, 1, 2, 4, negative 1, 1, and negative 2, 4. Negative 1/2 x squared, if x equals 0, then y is equal to 0. If x is equal to 1, 1 squared is 1 times negative 1/2. 2 squared is 4 times negative 1/2 is negative 2. 3 squared is 9 times negative 1/2 is negative 9/2, or negative 4 1/2. 4 squared is 16 times negative 1/2 is negative 8. So we got 0, 0, 1, negative 1/2, 2, negative 2, and 3, negative 4 1/2. Same points on the other side, negative 1, negative 1/2, negative 2, negative 2, and negative 3, negative 4.5. So we have a graph that has been reflected about the x-axis and widened by a factor of 1/2. Reflected about the x-axis and widened by a factor of 1/2. So the properties of these graphs, ax squared, when a is positive, the graph is going to open up, and if a is less than 1 greater than 0, the graph will be shorter than that of y equals x squared. Shorter than that was what I was calling widened. If the a is greater than 1, then we say that it's taller. So original graph y equals x squared, shorter means it's below it. Taller means it's above it. When a is less than 0, the graph will open down with the same restrictions. When the a is a fraction, it'll be shorter or wider. When the bigger than 1, then the graph will be taller than that of y equals x squared. And this concludes the video for section 10.4, graphing quadratic functions using transformations. Objective 3, graph quadratic functions of the form f of x equals ax squared.